So now that Angular signals have been around for a while, we're starting to see some patterns emerge. The pattern that we're going to look at today is our Redux-ish and really illustrates how RxJS and Angular signals are better together. First, we're going to look at the completed application so we kind of have a sense of how it works. So I've got my, I can say that I'm a team leader, and here are my list of team members, and I can pick one, and I see a loading indicator. I see their name up here, and I see their list of tasks. I can show only their incomplete tasks, and I can mark tasks as completed. Okay, so it's not a huge UI, but we have limited time to build this thing. So I'm going to move to the unfinished one, and we can tell because it doesn't do anything when I pick somebody from the list. So this is the one we're going to start with. Now, I already built the HTML because y'all don't want to sit and watch me create this HTML. We see here we've got a change that is bound to an onSelected method. We've got our checkbox here, this guy over here, its change tied to an onFilter method. And then when we check the little box on the changing the status of our completion status on our tasks, there's a change event on that on change status. If we look at the component, I am hard coding all the signals that we're binding to just to default values, and our methods are empty because we're going to build the service. All right, so here's the service. That's pretty much it. So we obviously need more code here. We have the interface for ToDos, but that's obviously not enough for managing the state of our component. So what state do we need? Let's define a second interface. So I also have a method down here that just maps an error response to an error message. Okay, so we're going to export an interface, and I'm going to call it ToDo state. So what do we need? Well, you saw that is loading flag, so we probably want an is loading indicator of some kind so that the component knows when it's loading. We also need to know what member that was picked from this list. So I'm going to call that current member. And that member could be defined as a user, or it could be undefined. When the application first comes up, there is no person selected, so it would be undefined. We also need, of course, our ToDos, and that's going to be, a ToDo array. And hopefully we won't need it, but maybe we want an error string as well. That could be a string or null. All right, now when we start our application up or bring up this page, we want to ensure our state is our page is in a valid state. So we're going to define up here our initial state. Oops. My keyboard is crooked and kind of hitting the wrong keys. All right, so initial state. So here I'm just going to call it state. I'm really good at naming. And because it is now 2024, we are creating our services to expose signals. So our component would be working completely with signals. So this is going to be a signal of ToDo state. So it needs a default value, of course, initial value rather. So we're going to define our initial state here. Is loading when we first bring it up is going to be false. Current member, oops, that's a comma. Current member is going to be undefined. Keep wanting to put those semicolons. Member ToDos. Initially, we don't have a member, so we don't have their to-dos. We'll just leave that empty, and our error will be a null. So now we have our initial state for our application. So notice, however, that we've defined that to be private. So how the heck is our component supposed to get access to that? Well, what we're going to do is we're going to define what's called in Redux land or in NGRX land selectors. And selectors give us pieces or slices of our state. And these will make public. So these can be accessed by our component. So we're going to take each one of our slices of state that our component needs and provide that as a public property here. All right, so the first one I'm going to call is loading, and we're going to make it a computed signal, so it's read only. That way our service completely controls when our state is actually updated. So we're providing read-only values to the component. So our computed is going to give us this .state, and we need to open the box in order to access the instance of the object that's in that signal, and then we can call is loading. Okay, so you get the general idea there. I'm going to save some typing and paste this in, the rest of them in. So yeah, if you see me kind of glancing to my left here, I have some of the code here that I can paste in, so I don't have to quite type so much. All right, so here we have our selectors then. Each one of them is a computed property, and each one is providing the value of one of the slices of our state. Okay, so we've defined the state, we've defined the selectors. The next thing we want to do is define our actions. What actions does our component need to support? Well, the obvious one, of course, is selecting a team member. So, excuse me, our next question then is how do we want to react to that action? Now, we know that one of the things that we are going to want to do when the user selects a team member is we're going to need to go get some data. We're going to need to get those tasks for that team member. We know that that's going to be an HTTP request, which is asynchronous. It would be really nice if we could create a computed signal for an asynchronous operation, but we can't. It would be nice if we could create, and it's highly recommended that we don't update state in an effect. You know, there's a little flag, we can fake it, but it's recommended that you don't really use an effect for that. So this is where RxJS comes in. It can be really our best friend in this area. So what we want to do is we want to be able to react to the user selecting a team member. Now that drop-down box, that select box, is going to give us the ID of that selected team member. So what we want to do, since we want to react and then process an async operation, is we're going to use a subject. So I'm going to create a subject, selected ID subject, whoops, and it's going to be a new subject, and its type is number. And that's because the ID that we're getting from the drop-down list is going to be a number. Now, we then want a method that our component can call. I'm going to call it get ToDos for member. And we're going to pass in the member ID, which, as we said, is a number. And this is going to take that subject and it's going to next in that ID. So what this does is it emits that value into the subject. So in our constructor, we can react to that. So this dot selected ID subject dot pipe. Now we could also do an as observable here and put it into observable and react to that observable. But since this is all private and managed in our service, we really don't need to do that. That was very useful when we were using an async pipe because we could make that part public. But we can do this. All right, so what do we want our process to do then? What is our reaction for this action? Well, the first thing we probably want to do is set a loading indicator. So I'm going to just use a tap for that. And instead of writing all of the code in my pipeline to update the state for is loading, we're just going to call a method, set loading indicator, and pass it true. Okay, we don't have that function created yet. We'll create it in a minute. So we'll have to ignore our errors here until I get the pipeline done. Then we'll create these methods. All right, so the next thing that we want to do is we want to get the actual member that they pick so we can display their last name. So we could do that with a tap as well. This one takes that emitted ID and it calls us, and we'll call set current member, which is another function we'll write that takes in that ID. Now I have a user service that's already created. We're not going to spend time on that, but basically what that does is it manages the list of users that's in this drop-down box, kind of hiding behind our error here. And since it has that list, it can simply look up the member by ID. So we're not issuing an HTTP request. So we can just do that with a tap. Now, as you know, RxJS operators each come with some overhead in terms of processing, tearing or setting up and tearing down, etc. So as we go to tune this app, we would probably want to combine these taps into one that calls these two methods. But right now we're just wanting to be explicit to get in what we want. All right, so our next step then is to actually issue our HTTP request. And we need for this request to be flattened. So we're going to use a higher order mapping operator, switch map. And the switch map is going to take that ID again that's been emitted into our subject, and it's going to call get ToDos and pass in that ID. And again, we'll create these functions here in a moment. All right, kind of ignore this next part, but we're going to delay for a little bit. That's only just so that we can see our loading indicator. Otherwise, it's difficult to actually see it. It goes by too fast. So you wouldn't really do that in your real application. And of course, to make this go, we need to subscribe. And in our subscription, we're going to get back a set of to-dos, and we're going to update our state with that. So this dot set member to-dos and pass in those to-dos. All right. So yes, I know that we need to create all these methods. We'll do that in a moment, but there is something else that's missing here. Anyone want to guess what it is? I'll give you a hint. The golden rule of subscriptions is if you subscribe, you have to unsubscribe. So we're going to use take until destroyed. Now, if you're not familiar with that operator, I just did a YouTube video on that last week. So you can check out my YouTube channel, and I go into detail as to how it works and where it works and blah, blah, blah. Okay, so now we're ready to create all of these methods. So our first one is set loading indicator. So private set loading indicator. Yes. All right, so what are we going to do? Well, first of all, we need to pass the value. So it's our isLoading flag is going to be a Boolean. And what we're going to create here in these methods are basically, in Redux terms, are reducers. So what we're going to do is update our state based on that value. So what we're going to do is do this dot state. And since that's a signal, we're going to call the update in order to update that state. The update gives us the existing state that I'll again just call state. Again, good at naming things. And then we're going to define the new state. Now, as you know, if you just give curly braces to an arrow function, it thinks you're doing a multi-line function. So we need parentheses around that. Then we're going to, excuse me, then we're going to create new state from our existing state using the spread operator. So there we're creating a copy of the state, and then we're going to change our isLoading flag using our is passed in isLoading value. Excuse me. So that's how we're updating the state. Now, the next function that we need to create is set. Oh, did I still mistype one? Indicator, set loading indicator. There we go. All right. So the next one is set current member, private set current member. And this one we're passing in the ID, which is a number. And instead of watching me type that whole thing, I'm just going to paste it in, and then we'll talk about it. So, whoops. Yeah, because my fingers are not yet awake. It's morning here. All right, so the first thing I'm doing is calling my user service to get the current member. As I mentioned earlier, that's simply looking at the list that it's holding on to, its state for the drop-down list, and getting the current one. So that's not an async operation. Then it is updating the state using the same technique we're using here. We're updating the member with the member it found. This could potentially be undefined if it couldn't find it. And we're also setting the member to-dos to an empty array, because once we have a new member, we don't yet have their to-dos. Now we could make that a separate method, but I just put it as part of this. All right, so our next method is get to-dos. And I'm going to just paste that in here. All right, so get to-dos is where we are issuing our HTTP GET request. It is a parameterized query. We're using the user ID to get the to-dos just for the user. And you can sort of ignore this little bit. I'm using a public API up here, JSON placeholder for the to-dos, and the to-do titles are really long. I wanted them to fit nicely in my UI. So I cut the length down to 20. And then this calls a set error. I will paste that method. So if there are any errors, what it does is it updates the state with that error, calling the set error message function that I had down here to convert it, the HTTP error response, into something that we could display. Now, since this is being called by catch error, this function needs to either return, needs to either throw an error, or it needs to return a replacement observable. So we're returning a replacement observable that just is an empty array. So the last part here that we need is set member to-dos. And I'm going to go ahead and paste that as well. And this kind of does the same thing as the other ones. It's updating our state. So these are basically our reducers. This is taking the to-dos that we received. This one's called, scrolling up here, this is called by our subscribe when we get our to-dos. And so it's updating the state with those to-dos. And at this point, I'm setting isLoading to false. Now, if we really wanted to be explicit, we could call instead a set loading indicator and pass in a false here as part of this subscribe, or we could do those as tap operators up here in our pipeline. Okay, so that was our pattern here. We defined slices of state, which is what we're doing there using selectors. We defined an action that we reacted to using RxJS. And we created a bunch of reducers to update our state based on different parts of that action. Now, in order to actually get that to work, because it's still not working, we need to make a couple of changes to our component. So I'm going to change each of our properties here that are our signals to actually reference the ones from the service. And then in our onSelected, I'm going to call the method that we created in the service, get to-dos for member, and pass in the ID from our selected team member. So at this point, when we pick a person, we see our loading indicator, we see the name here, and we get our list of to-dos. Now, notice when we check this box, it's not filtering our list. That's because we haven't yet done that part. So what do we need? Well, we can follow our pattern again. So let's go back to our service, go down to our state. And here in our to-do state, we're going to add an incomplete only flag for our little checkbox there. And of course, we get an error because we also need to define it in our initial state. So incomplete only, we're going to originally set it to false so that we see all of the to-dos. Then we can create a selector for it. Again, I'll just paste that. So we have that flag available for the component should it want to use it. Now, the next thing is our action. So our action is, of course, to check the box. So we could do what we did last time and create a subject for it that reacts to the user clicking on that box. However, our action, our response to that action is to simply filter this list that we already have in our state. We already have the member to-dos. We're just going to be filtering it. So there really is no reason to add in a subject at that point. We can simply do another signal. So we're going to do a computed signal. I'm going to paste that in also. And it's called filtered to-dos. So what this does is if the template references this to-dos, filtered to-dos signal, every time the incomplete only filter changes, it will re-execute this code. And if that flag is true, it's going to filter to only those that have its completed flag set to false. Otherwise, it's going to return our full set of to-dos. So a rule of thumb that I use is if the action requires an HTTP GET request, you might want to consider using a subject, especially if you're going to have continual items emitted into that subject, like we are picking different team members. If the action is just synchronous, like filtering our list, we can just simply use another computed property. All right, so next we're going to have a function that the user interface can call, our component can call, called filter to-dos. And what that is going to do is update our state. Updating that state then causes our incomplete only to change, which will cause our filtered to-do to recompute. So the last thing, of course, that we need to do is modify our component. So when the user picks a filter, we are going to call filter to-dos and pass in whether the box was checked or unchecked. And the other thing is our to-dos for member that we're displaying. We're no longer going to use the standard set of to-dos. We're going to instead called the filtered to-dos. So now again, we can pick our person, see the loading indicator, see their name, see the tasks that are completed, click on the box, and now it only shows the incomplete tasks. However, if we pick one of these, it's not filtering out. And that's because we are not yet updating our signal for this check. So our last step then for our code for today is to implement that. So again, we start with the state. Well, we already have the state for this. I'm scrolling down to the bottom here. We already have this completed state here. That's where we're keeping track of the to-dos completed state. And up here at the top, we are defining the initial state by defining the member to-dos as an empty array. Now we don't need to create a selector for that slice of state because the component doesn't access that all by itself. It instead binds to the to-do item, so we don't need to worry about that either. The main things that we do need to worry about is the action and our reducer that's going to update the state. So I actually did this as one method. So I'm going to paste that in, slide down here to my public methods and paste that in. So here is my change status. So we're going to call this from our user interface or from our component. We're going to pass in the task. Which one did the user click on? We're going to identify whether they checked or unchecked it. Then we go through and we update our list of tasks. So we're going to take our to-dos, we're going to map them, find the one particular one that was clicked on, and change its completed status. Then we're going to update our state with that new list of tasks. This is required because in order for the signal to emit the new value, or not emit, in order for the signal to recognize that the value was changed, you actually have to change the value, not just change the internals of that. So if we just change the object inside this array, we're only changing the internal data, and this reference to that array itself is not changed. So we need to create a new array in order for the state to correctly be updated. And I guess I don't need that comma there. All right. So our last step for that then is to modify our UI. And so we're calling change status, passing in the task, and whether or not the checkbox was checked. So trying it one more time. We get our loading, we get our person, and now you can see that some of these are completed, some not. If we check the box, we get only those that are not complete. If we check one, it is now off the list because it's been correctly filtered off. Okay, so if you've used Redux or NGRX, a lot of the terminology here probably looks familiar and somewhat the processing, but this is only Redux-ish. So we started by, let's see, go back to the service. So we started by defining our state. We set an initial state, defined selectors for our component to access, defined our actions, either by using RxJS or simply reacting with a method. And we have reducers, which are changing our state. So I hope this was useful. Thank you very much.
Thank you, Deborah, for this awesome presentation and showing us how we can find synergy between these two reactive words you right now have in the Angular. Right now, we'll move to the Q&A session because I saw there were already some questions. And the first one was from the Marcus. So he's asking whether that wouldn't be separate signals better for performance, since every computed is triggered when the state is changed instead of updating the exact piece of state.
Computed are all memoized, so there is no recalculation or anything done for any of those if they haven't changed. And since each one of those are separately defined as a computed, they should be separately changed in the UI. So I don't believe so. I am not sure of a good way to test that, but I would think that it wouldn't cause a problem.
Yeah, that shouldn't be a big problem even if they rerun. But as you said, mostly they should be memoized. So shouldn't this problem be a high priority, would say, even if it occurs? Okay, so we have like another question. From Lisa, what the reason for choosing computed in general besides the read-only fact?
We want to use computed in that case because it gives us a way to react to changes. By having a computed signal, it will be notified every single time any of the referenced signals change. So that allows us to react to those state changes and display the value. So if we just created each one as their own separate signal, they wouldn't correctly react to each other and provide that reactivity that we're looking for, which is one of the key benefits of using signals.
Mm-hmm. Okay, thank you. There is another question from Anna. And here it's in the example you showed, do we actually need to unsubscribe? It was switch map, HTTP call, self-closing.
Well, in our particular example, we actually were subscribing to a observable, that subject that would keep potentially emitting based on what's going on with the code. So that is one thing. And the second thing is, even with a one and done observable, that's an HTTP, you still run the risk of the user leaving before the data has come back. So you pick a user and you went, oh, never mind, and you go to a different option in the application, or click on a different feature or whatever, it still would not have terminated the subscription. So it's normally a good practice every time you subscribe to unsubscribe, and it's pretty easy with the take until destroyed.
Mm-hmm. Okay, and we have another question from George. What the advantage of adopting Angular signals in comparison with conventional change detection with Zone.js? And I mean, besides that, it's lighter and more performant.
Well, for one, the Angular team is moving rapidly to try to remove Zone.js. So it would be nice to move to signals to prepare for that. And another reason is that Angular signals reactivity can be really nice to have. I know when I first started with Angular 100 years ago, that one of the things I really missed having were computed properties. And these computed signals are basically those computed properties where you can very easily react to changes that are happening with very little code. I have a shopping cart example that I did with all computed signals that made the whole thing about recalculating your taxes and recalculating the shipping and all of that kind of stuff really easy because of the signals. So you can save coding time, you can have your code much more reactive and easier to code because these automatically react for you, and they are lighter and more performant. Angular team is getting rid of Zone.js, so those are a bunch of reasons.
Okay, and we have probably the last question. What about effect? It was not necessary here, or you try to avoid it as much as you can?
Well, the biggest problem with effect as it is now is we're technically not supposed to update state within an effect. And so much of what you saw was all about updating the state. Okay, we're updating state.update something. Almost every routine that we had some updating of the state. And, yes, the effect has the little flag that you can tell it, oh, no, I know better and I won't muck with it. But I am going to modify state. So I personally have been concerned about using effect for that reason. Plus, as far as I know, it's still in developer preview, like they're not quite finished with it. Hopefully they're thinking about some of these things. So I have been, yes, kind of avoiding it unless I just need to do a debug kind of statement with it.
Okay, Deborah, so that was the last question. We want to thank you for finding time for us, just giving us an awesome presentation. Thank you. And as I said, hopefully we'll see you on other future meetups, and have a nice day.
Thank you. You too.